Okay, so we have another sheet here, and this is on the fifth type of operations that we can do with functions. So we have adding, subtracting, multiplying, and dividing, which you would expect with functions, but then we have this fifth one called function composition, or the composition of functions. And it's written in a way that's really not intuitive at all. It's this F with this little tiny circle in the middle and a G. It almost looks like a degree symbol, but it's not up above like this. It's just right between where an operation would be. Right? So then we would read this F of G. That's how we would say that. And then with this 3 behind it, we would actually say F of G of 3. Right? So remember, before we would say F plus G of 3 or F times G of 3, but now function composition, we just read that as of F of G of 3. Right, and again, I don't like this notation because I just don't think it's very intuitive. But really what this is saying is they want you to take and do F of G of 3. All right, so in other words, they want you to take and figure out what G of 3 is. It's going to have some numerical value. And then they want you to take that value, whatever you get, and plug it into F. All right, so let's do that. So ignore this F on the outside and just look, and they're saying they want you to find G of 3. All right, so whatever function in this notation is closest to the parentheses here, either it's a number or it might just say X or something like that, whatever function is closest to that, they want you to plug that number in to that one first, so G of 3. So let's do that. And I'm going to just kind of carry this F along, but I'm just ignoring it. It's still there, but we're not going to do anything with it. All right, so it's asking me to find G of 3. So again, G of X is X squared, so it's telling me plug 3 in the position of X in G. So here it's going to be 3 squared. All right, so G of 3 means plug 3 in for X, and we get 3 squared. All right, now 3 squared is 9. So what this then is asking me to do is, now that I found G of 3 and I fill it in this spot, and it's G of 9, it's F of 9. Now they're asking me to plug 9 into this function F. All right, so I'm going to take F and I'm going to plug in 9. So it's asking me to do 3 times 9 minus 5. 3 times 9 is 27, minus 5 is 22. Right? So what I do is I plug a number into G. All right, so let's see. Remember when we started talking about functions, we talked about them kind of like sets like this. All right, so let's say this is our function where we're going to take it here, and this is G, and then we take F. All right, so this circle right here is the domain of G. So here's 3 in it. All right, it's asking me to transform it through G, all right, which is X squared. So it's saying take 3 and match it up in this right here, which is the codomain of G. Match it up with 3 squared, all right, which is 9. Now this set right here, which is the codomain of G, happens to be the domain, or at least in the domain of F. Right, so now it's asking me to take 9, what we got here when we plugged 3 into G, and it's asking me to send it through F, which is 3x minus 5. All right, so I'm going to take 9 and transform it using 3x minus 5, so that's the 3 times 9 is 27 minus 5, which is 22. Right, and if we were to go directly, or again, I guess we still need to think about it as breaking it down, but this, to go from 3 right to 22, we call F of G. Right, that we're transforming it, we're having it go through both functions, but we're going to call that F of G. All right, so that is what function composition is. It's taking one number that's in the domain of G, sending it through G. It comes out, that number happens to also be in the domain of F. And then we are going to send it through whatever the function F is, and we get some number out. All right, hopefully that was kind of not too rambly and somewhat intelligible. All right, let's try another one. So here it's asking us to find F of g of 10. Again, I think this notation is a little bit more intuitive because it's telling us to find g of 10, and then whatever we get here, we want to plug it into f. All right, so let's find g of 10 first, and then we'll plug that into f. So here's g right here. Right, I'm going to carry that f along, and then g of 10 tells me to do the square root of 10 minus 9, because that's what g is. It's square root of x minus 9. The x value they gave us was 10. All right, let me just simplify that. That's f of the square root of 1. In other words, just f of 1. All right, now that we have found that it's gone through g, and we're at this point right here, now it's asking us to plug this into f. All right, so f tells us take whatever x value we have, multiply it by negative 9, and then subtract 9 from it. All right, so we're going to get negative 9 times 1 minus 9, and that would just give us negative 18. All right, so when we do f of g of 10, again, both these stay the same thing. I just think this notation is a little bit more intuitive. It says do g of 10 first, and then whatever we get here, plug it into f. All right, so that's exactly what we did there. All right, let's try one more, and then I'm going to ask you to stop the video and try these last two on your own. Okay, so here it's saying f of g of 12, in other words, f of g of 12. All right, so the first thing it's going to ask us to do is find g of 12, and here's what g looks like. Okay, so then here we are going to do f of square root of 12 minus 8. All right, square root of 12 minus 8 is the square root of 4. Square root of 4 is 2. So again, this f is just carried along right here because it's waiting for that value to come out like here, so it knows what to plug into f. So now we know that the value that we're supposed to plug into f is 2, and all along he's just been waiting to hear what it is. What are you going to plug in? Okay, so 2 here, so we plug 2 into f. So then this is going to give us negative 4 times 2, that's what we're told to plug in, and then plus 2. All right, that gives us negative 8 plus 2, and that gives us negative 6. Okay, now I'm going to ask you to pause and do these two, but before I do that, I just want you to notice that they've reversed the g and the f here, so that what this means is g of f of negative 2. So first, we're actually doing this in a different order now. We're going to start on this end. Actually, our picture is just going to look like this instead. Here's, this is f right here. And then we get the codomain of f. That also happens to be something that is part of the domain of g, and so then whatever we get here, right, when we send negative 2 through, negative 2 is going to map to something in here, which then we're going to send through g. So we can do them in different orders, but always remember that whatever is closest to this right here is the thing that we plug in first. All right, so pause the video, and I want you to try 4 and 5 on your own. Okay, so let's see how you did. So f of negative 2. So I'm just going to keep carrying the g along. It's just waiting to see what we want to plug into g. But for right now, it says do negative 2 in f. So this is negative 3 times negative 2. Again, this stayed the same, and this I filled in with the negative 2 that it told me to fill in here. And then plus that 4. All right. So then, again, g is waiting to know what's the value that's going to come out here that's going to go into g, right? So right now it's just kind of waiting. So negative 3 times negative 2 is positive 6, plus 4 is 10. Right, so we got g of 10, and now g is x squared, so it's telling us to take 10 and plug it into x squared, and so we get 100. All right, same thing here. This was g of f of 2. All right, so we're going to do f of 2 all the while. G is waiting patiently. So f of 2 says to do negative 2 times 2 plus 1. All right, so g of negative 2 times 2 is negative 4 plus 1 is negative 3. All right, so now g knows negative 3 is coming in. All right, so we're going to put negative 3 in there. So we're going to get square root of negative 3 squared minus 5. That gives us the square root of 9 minus 5, which is the square root of 4, which is just 2. Okay. All right. Hopefully you're feeling okay about those. Let's move on to this next section. Because again, just like in the last worksheet, I want you to notice that sometimes they'll give us a value for x to plug in, and other times they don't. They just say, just leave it as it is. Right? So this says f of g of x. Right, so what it wants to do is it wants us to take the whole of g of x, all right, which is, let's write that out. The whole of g of x is x to the 4th. All right. So it wants us to take and replace every x in f of x with x to the 4th. All right. So this is going to be negative 9 from here, and then we're going to replace x with what it tells us to replace it with, x to the 4th plus 3. All right, there's no simplifying we can do. We can't combine, distribute, anything like that. So this is just going to be negative 9x to the 4th plus 3. All right, so again, what we do is we just replace g of x in here with what g of x is in the problem. It's just x to the 4th. So from here to here, we just replace g of x with what it says in the equation. And then we just use our f function and fill in everywhere we see an x with this right here, x to the 4th. All right, let's try the next one. Again, this says f of g of x. All right, so I'm going to write f, and in place of that g of x that I had right here, I'm going to replace it with what g of x is, which is x plus 2. All right. Things get a little bit weird here, and until you're used to it, I think it does feel kind of weird to be doing this. But now it's telling us to take and replace every x that's in our function f. So right here, that's just kind of acting as a placeholder until we tell what to fill it in with. So again, up here, it was acting as a placeholder for the number 2. All right? So it's just saying everywhere you see an x, I want you to replace it with a 2. But now what it's saying is everywhere you see an x, I want you to replace it with an x plus 2. Right, so we're going to write this as 2 because there's a 2 at the beginning, and in place of x we're going to write x plus 2 and then minus 5. Right, so this is exactly what f was, except where we saw that x before, we replaced it with x plus 2. Right, now this we wouldn't leave like that. We would multiply things out. We would distribute that 2, so this will become 2x plus 4 minus 5. And then we can combine these two, and we would end up with 2x minus 1. All right, let's try another one. All right, same thing, f of g of x. So it's asking us to take f, and we're going to replace this g of x with whatever g of x actually is. So g of x is actually x minus 3. So we're going to replace that g of x with what we're told g of x is, which is x minus 3. And again, just like before, this says go into the function f and replace every place that you see an x with an x minus 3. So here I see an x squared, so I'm going to replace that x with x minus 3 and still keep the squared part, and then plus 7. Okay, let's multiply this out. So x minus 3 times x minus 3, that gives us x squared minus 6x plus 9 plus 7. All right, and then this is x squared minus 6x plus 16. Final answer. All right, I'm going to ask you to pause the video, and I want you to do 9 and 10 on your own. So again, just like before, the thing that's different about this is now it's g of f of x. So we're going to be replacing this with f of x, all right? But again, whatever's closest to this, when you're in function composition, whatever is closest to this is what you would do first, f of x, and then fill that in place for g. So go ahead and do those two, and then when you're done, come back and I will walk through them, and hopefully you got the right answers. Okay, so this says to do replace f of x with what it is right here. So this is going to be g of, and in place of f of x, we're going to write 4x plus 3. Right? And what this says now is go into g, which is x squared, and everywhere you see an x, replace it with 4x plus 3. All right, so there's the only x that we see, and it's squared, so we're going to take that and we're going to write 4x plus 3 squared. All right, so literally I just take that x out and I replace it with 4x plus 3. All right, 4x plus 3 squared is 16x squared plus 24x plus 9. And that would be our answer. All right, the next one, again, it's g of f of x. Now I'm going to replace this f of x with what f of x is, which is x minus 1. So instead I'm going to get g of, and in place of the f of x that I had right here, I'm going to replace it with x minus 1. And now this is saying that I want to fill in anywhere I see an x in my expression for g, I'm going to replace it with an x minus 1. All right, so here this says x squared, so I'm going to replace that x with x minus 1, still keep the squared, plus 2 times, and in place of x, I'm going to put in x minus 1 minus 8. And then we just multiplied out. So x minus 1 squared is x squared minus 2x plus 1 plus 2x minus 2 minus 8. Then combine like terms, so x squared has nothing to combine with. Negative 2x and positive 2x, they cancel. Then we have positive 1 minus 2 is negative 1, and negative 1 minus 8 gives us negative 9. Well, that's fun. I certainly wasn't expecting it to be a difference of squares, so I would say you could just leave it like this, or in this case, maybe you would want to write x minus 3 times x plus 3. I'm not sure. I would probably still leave it like that, but okay, hopefully you got those answers. All right, let's just try one of these, and then I'm going to stop this video here. This, I feel like kids tend to struggle with this, because this is saying, okay, here is some function, like we got an x squared minus 9, or 16x squared plus 24x plus 9, or an x squared minus 6x plus 16. This function is composed or made up of f and g, right? So I took the function f and I took the function g, and it created this function right here. Right, so this is the answer to a problem that, like what we would have just done. And it's saying, okay, I'm telling you that f was x squared. And they're saying, what did g have to be in order for you to get this as the answer? So again, h of x is the answer. It's the composition of the two functions. And it's telling me that the last step, right, when I do this, again, this says f of g of x, all right? This last step is to plug something into x squared. and get that, right? So we have to think about what would we plug in here and square it and get that. All right, so hopefully it's not too much of a stretch when I say that g of x is going to be 2x minus 5. All right, let's try it then. So that's saying that if we do f of g of x, and this is the g of x that I say is the right one, that we should get this. So let's try it. F of g of x means fill this in with what we think is g of x, which is 2x minus 5. So this is f of 2x minus 5. And then whatever this is, we do f to it. All right. In other words, it means we plug this into f. And again, the f that we're given is x squared. So that means plug this in anywhere we see an x in here. In other words, we're going to get 2x minus 5 plugged in as the x in x squared. And that's exactly what h is. All right. So when we do these, and again, we'll do more of these in class on Thursday, but I'm just hoping that you're not in overload right now. That when we do these, we're going to look and we'll notice kind of like a function inside another function. Like here, the x minus 5 is inside this square root of x, right? Or this 5x plus 1, sorry, my paper might be moving too low. This 5x plus 1 is inside this function of squaring. Here, this, well, this could be really an inside, like an inception, right? This negative 3x minus 2 is inside a cubing, which is inside a square root, all right? So we're going to be looking for functions inside of functions because that's exactly what function composition does. It shoves one function inside another. So here, this was shoving 2x minus 5 inside the x squared function. Okay, I'm going to stop for now. That's all I have to say. Bye.